I'm going to be going back over the mole calculation notes. I'm adding a few things into it that may or may not make things easier for certain people. I'm also going to make sure that I include molar volume this time around. So let's get started. You guys know that a mole is a number, and it's a really, really big number used to count atoms or molecules. So it's a grouping number like a dozen. The number of things is called Avogadro's number, and the actual number is 6.02 times 10 to the 23rd, which is really, really big. And you guys know that molar mass is the mass of 1 mole of an element. You can find the molar mass on the periodic table. The atomic mass units shown on the periodic table is the same as the number of grams in 1 mole of that element. Here's a couple of examples. If you have a periodic table handy, you can check and see that these are the masses that you can find for the elements carbon, aluminum, and zinc on the periodic table. Here's a graphic showing how to do conversions. So if you start with moles here in the middle, moles are central. You're going to you can convert to either particles, grams, or liters of a gas if it's at standard temperature and pressure, which is what STP stands for. Here's where we're going to use a possibly different method. If you don't like the conversion factor method, we're going to use what I'm going to call the DEMO method. DEMO stands for divide in, multiply out. So the numbers that you see on each arrow, if you're going, let's say, from moles to particles, you're going to use the number 6.02 times 10 to the 23rd. And if you're going from moles to particles, since you're going out, you're going to be multiplying by that number. And if you're going from particles to moles, you'll be dividing by that number. Similar thing for moles to liters of a gas, you're going to use 22.4, multiplying if you're going out, dividing if you're going in. And the only thing that's unique to the particular thing that you're doing the calculations on is formula weight, and that's only if you're going to and from mass in grams. And here again, if you're going out, you're going to be multiplying by the number of grams in 1 mole, or if you're going in, you'll divide. So here's kind of a handwritten, well, not handwritten, something that you might be able to draw out for yourself to use, where the conversion factors are shown in blue, and the materials that you'd be going to and from are in the boxes. Again, moles are central. You'll either be dividing by or multiplying by the number in blue. The only number that's unique to the particular item is its molar mass. All the other numbers are standard. All right, if you're using the conversion factor method, you're going to be using one of these 3 conversion factors. 1 mole is Avogadro's number, or 6.02 times 10 to the 23rd, or you're going to be using 1 mole as the molar mass in grams. That one you have to provide the specific number for your item. And if you're doing calculations on a gas at standard temperature and pressure, 1 mole of a gas is 22.4 liters. All right, so here's some examples. How many moles of carbon are in 26 grams of carbon? Here we're going from grams to moles. Moles are in the center, so you're going to be dividing in. You need the molar mass for carbon. If you look that up on the periodic table, it's 12.01 grams is 1 mole. So I take the number I start with, 26 grams, I divide it by 12.01, and I get 2.2 moles. If I'm using the conversion factor method, I write down the number I start with, 26 grams of carbon. I'm using the conversion factor, 1 mole of carbon is 12.01 grams of carbon. I'm going to make sure I put the mass on the bottom so I can cancel those grams out. And 1 mole of carbon goes on the top, so I can cancel my units out. Essentially, I'm doing the same math I did on the previous slide, dividing 26 by 12.01 to get 2.2 moles of carbon. All right, here's another one. How many atoms are in 2.5 moles of carbon? Here I'm going from moles, which is what I'm given, to molecules, rather atoms, not molecules. And moles to atoms is going out, so I'm multiplying out. The conversion factor on the line between moles and molecules or atoms is 6.02 times 10 to the 23rd. So I multiply 2.5 moles by Avogadro's number, and I get 15.05 times 10 to the 23rd. Looks like I didn't use sig figs right there because there should only be 3 sig figs in that number. So it should be like 15.1 instead of 15.05. Here's it using the conversion factor method. Again, I'm starting with the same number, 2.5 moles of copper. And I want to put the part of my conversion factor, 1 mole, that has the same units that I'm starting with on the bottom, so it cancels out. And then the other part of my conversion factor goes on the top. Then I just multiply through and I get the same number I got before, only this time it looks like I used sig figs correctly. 1.51 times 10 to the 24 atoms of copper. If you're doing molar volume, same kind of math. If you're trying to find moles of oxygen and you have 5 liters of a gas at STP, here I'm going from liters to moles, so I'm going in. Divide in, my conversion factor, or the number I'm going to be dividing by, is 22.4 liters. So 5 divided by 22.4 is 0.22 moles of oxygen gas. It looks like I should have put 5.0 there. Hard to draw with a trackpad. And that makes the answer be 0.22 moles of oxygen gas. If you're using conversion factors, here you're starting with the 5 liters of a gas. You put that in the first position. You add in your conversion factor, and my conversion factor for that is 1 mole is 22.4 liters. So I'm going to put the liters part here on the bottom so I can cancel the unit liters out, and 1 mole goes on the top. So when I do that division, I wind up with 0.22 moles. Looks like I'm just repeating myself. If you're doing 2-step conversions, you need to do that in 2 separate steps using the divide in, multiply out method, or you can stack them together using the conversion factor method like we've done in the past. I'm not going to go over any examples of those. Remember, here is the graphic that will tell you how to do those conversions. Remember to use DEMO, divide in, multiply out. So anytime you're starting with something on the outside, particles, liters, or grams, and you're going in, you're going to be dividing by the conversion factor in blue. And if you're going out, you're going to be multiplying by the conversion factor in blue. If you're using The conversion factor method, where you're canceling out your units, you're going to do it the same way you did it in the past. I have posted a couple of problems for you to practice on, and some additional videos for you to look at if you need extra help.